Good morning, guys. Welcome to today's lesson, May 6th, Factoring AM. Let's take a look at today's do now. Simplify the expression 4x times x plus 3 squared. Now, so with this, we got to think about, should we be distributing first, or should we be factoring in this exponent of 2? If you remember your rules with PEMDAS, we look at exponents first, so we have to attack that x plus 3 squared. And that's essentially, guys, x plus 3 times x plus 3. Alright, so that's a binomial times a binomial, and that's why we'll set up box method 2 by 2. So we'd have x plus 3 and x plus 3. So x times x is x squared, x times 3 is 3x, x times 3 again, 3x, and 3 times 3 is 9. So take a look, we have some like terms. So this would be x squared plus 3x plus 3x plus 9. Like terms, 3x and 3x would make 6x, so we have x squared plus 6x plus 9. Alright, that's the trinomial you would get after you do x plus 3 squared. Now factor in, we still have that 4x out front. So now it's 4x times x squared plus 6x plus 9. Alright, so now we'll distribute that 4x to everything. Alright, so 4x times x squared is 4x to the third power. Remember your invisible ones, that's an exponent of 1. Alright, 4x times 6x is 24x squared. Another invisible 1 here. And we have 4x times 9, which would be 36x. And now you're done. So the tricky part here, guys, you have to factor in that exponent of 2 first before you distribute. Alright, so a combination of box method and the distributive property. Alright, next, factoring. So remember what type of factoring we always check for first. GCF. Is there a common factor between x to the 4th power and 81? There is not, but this is the other type of factoring that we looked at yesterday, which is dots. These are both perfect squares. So we're essentially taking the square root of x to the 4th, which is x squared. Just keep in mind where that's coming from, because x squared times x squared is equal to x to the 4th. Alright, and the square root of 81 is 9. And remember, we expand that to the product multiplication of two binomials. So you write your x squared and your 9, your x squared and your 9, and then one of the signs is positive and one of the signs is negative. One addition, one subtraction. Now also factoring, guys, we're not done. Alright, there's dots again. So right here would be another example of dots. Those are both perfect squares, because x times x gives me x squared, and 3 times 3 gives me 9. This would be x squared plus 9 still, and then we would have x plus 3 and x minus 3. That x plus 3 and x minus 3 comes from dots when you do x squared minus 9. Alright, so here would be your final answer. Alright, and one more for your do now. Another example of what we would use the box method for. X plus 4 times x plus 6, a binomial times a binomial, 2 by 2 box, x plus 4 and x plus 6. X times x is x squared, x times 6 is 6x, 4 times x is 4x, and 4 times 6 is 24. Like terms. No like term for x squared, but we can combine 6x and 4x so that we get 10x, and no like term for our constant, 24, and we're good to go. So multiply, make sure you combine your like terms. Alright, guys, so another lesson of just pure review from Algebra 1, AM factoring. Alright, so let's take a look at that. The standard form of a quadratic trinomial is ax squared plus bx plus c. The type of factoring can depend on the value of a. When a is equal to 1, we use the AM method of factoring. Alright, guys, a being 1, that just means the value in front of x squared is 1. The coefficient, the number in front of x squared, is equal to 1. Now, essentially what that means is that you're not going to see anything in front of x squared, because remember those invisible ones. Alright, if there's nothing in front of your x squared, that's 1, and that means we're going to be using AM factoring. And AM stands for add and multiply. We just have to know what do we know about adding, what do we know about multiplying. But let's take a look at this first trinomial, x squared plus 10x plus 24. The a value is the value in front of x squared, right? That's just 1. The b value is 10. That's the value in front of the x, not the x squared, the value in front of x. And the c value is the constant, the number on the end there, which is 24. So when we're using AM factoring, it's a trinomial, and the a value is equal to 1, which here we can see that it is. Alright, so we're going to find the values, find the numbers that add to 10 and multiply to 24. Your Algebra 1 teacher might be writing AM like that. Alright, we need values that add to 10 and multiply to 24. Alright, what are those two numbers? Add to 10, multiply to 24. That would be 4 and 6. Right, because 4 plus 6 is equal to 10, and 4 times 6 is equal to 24. Alright, so now we write it just like we did, guys, with dots. We wrote it as two binomials times each other. We're going to do the same thing here. We write it as a product of two binomials. The factors were 4 and 6, so we write x plus 4 and x plus 6. Why should you have known that already? Guys, that's our do now question. We multiplied earlier x plus 4 times x plus 6, and we ended up with this initial trinomial, x squared plus 10x plus 24. That's why that do now was there. Alright, because remember, it's good to think about what actually factoring is. When you factor, you're finding out what are two values or two expressions that are going to end up multiplying to the original expression. So if you were to multiply that out, just like we did with the do now, we would end up with the original. Okay? So let's try it out. Just straight factoring. We're going to work on a couple of them. You can pause the video at any time. This is just Algebra 1 review. So let's take a look. X squared plus 4x plus 3. And I wrote off to the side here, guys, if you have trouble, write down the factors of c. Remember, this is a, b, and c. So the factors of c, right? 3. What multiplies? I said what that means is factors, right? What multiplies to 3? That would be 3 and 1, right? That equals 3. But also keep in your back pocket, guys, other variations. It's actually, you might think it's just 3 and 1. It's actually not. We could multiply two negative values. So negative 3 times negative 1, that would also give you 3. Alright, but keep in mind they also have to add to 4. So which one of these add to 4? You would see it would be the first option, right? Because 3 plus 1 is equal to 4. So we write this as a product of two binomials, x plus 3 and x plus 1. Keep in mind, guys, why this works. Because 3 plus 1 is equal to 4, and 3 times 1 is equal to 3. Alright. It's also good to write in AM here. Alright, we need them to add to 4 and multiply to 3. Alright. Okay, now, very similar looking trinomial, however, we need them to be factors what multiplies to 3, and this time adds to negative 4. This would be x minus 3 and x minus 1. Why does that work? Once again, if we were to multiply these out, we do end up with 3, and if we were to add them, that comes to negative 4. Negative 3 and negative 1, add them together, you get negative 4. Alright, couple more, and you're going to have a lot of practice with this on next week's Delta Math. Alright, x squared plus 7x plus 12. Once again, why is this AM factoring? We would always check for GCF first. There's no common factor between all three of those terms. We would check for dots, definitely not dots because there's no subtraction. Also, dots is for a binomial, 2 terms. This is 3 terms, it's a trinomial, and the value in front of x squared is equal to 1. So we determine that it's AM factoring. We need the values to add to 7 and multiply to 12. So what multiplies to 12? 3 and 4. That multiplies to 12. Does that add to 7? It does. Now, just to show you something that wouldn't work, like if you said maybe for 12, like 2 and 6. Okay, great, yeah, that multiplies to 12. But if you add those together, that comes to 8, so that's no good. Alright. So it'd be x plus 3 and x plus 4. It's quick, guys. It's not a lot of work. It's just a lot of thinking. All right, you have to know your factors. You have to know what multiplies to something and also adds to something. Okay. Here, probably the trickiest one. Another example of AM factoring. We need 2 values that add to 10 and multiply to negative 24, not positive 24. Always factor in that sign that's in front of the value. All right. So what multiplies to negative 24? Now, guys, they have to be 2 different signs because it's multiplying to a negative. Alright, when you multiply numbers that are different signs, so positive and negative and positive, you end up with a negative value. Okay, so different signs. So what multiplies to negative 24? It would be these 2 values. They multiply to negative 24. But do they add to 10? No, they do not, right? This comes to negative 2. Alright, so what are those 2 values? Think, alright, pause the video, think about that. I want you to get this one on your own. What multiplies to negative 24 and adds to 10? It would be 12, and it would be negative 2. And you're done. Just check it, right? 12 times negative 2, right? That does equal negative 24. And when I add those together, right, that does come to positive 10. Alright, so like I said, you're going to get a lot of practice with this on next week's Delta Math. Remember, just in general with factoring, guys, you always check for GCF first. Alright, do we have a common factor? Alright, in all these we don't. When do we use AM, right? It's a trinomial, and the A value is equal to 1. Alright? So that's all for today. Your Delta Math is due tomorrow. Factor that in. Message me and remind if you have any questions. Have a wonderful rest of your day, and I'll see you mañana.